All right, so I really just wanted to just run through this really quickly using this little remember guide from your textbook, just so we've got some sort of concrete notes on this. It says for damped functions, y equals e a to the x times bx and y equals e a to the x cos bx, the following. Sine bx and cos bx are functions which oscillate between plus or minus 1. Okay, so they're going to have an amplitude 1. So they're going to go from 1 to -1. That's sine bx and cos bx. So I've drawn sine bx, cos bx here, just by setting my a value to 0. Because when I set my a value to 0, e to the 0x is equal to 1. So that's what I've got there so far. The multiplier function, e to the ax, this is the multiplier function, alters the amplitude according to the value of a, constraining both sine bx and cos bx between plus or minus e to the ax. And you've seen that as well. Changing my multiplier function changes the way this function is going to look. Okay, and then this next bit here. The limit as x approaches infinity. So the limit as we move along our x-axis towards positive infinity, oops, go the other way, towards positive infinity. If a is less than 0, so there's a is less than 0, as x approaches infinity, then y approaches 0. That's what this means here. As x approaches infinity, then the value of this function, if a is less than 0, will be 0. And if a is more than 0, the limit approaches, the limit of x is, the limit as x approaches infinity is plus or minus infinity. So it goes off into space here, off into space here as x approaches infinity. That's the same for sine bx, it's the same for cos bx as well. Now, the other little bit of note here that they do, I'll just move this out of the way for a second. The other little bit of note here is the limit as x approaches negative infinity. So I'll just move my whole screen over here a little bit. So as x approaches negative infinity, the opposite is true. If a is less than 0, which it is right now, as x approaches negative infinity, then my function is going to be positive infinity or negative infinity. That's where we're heading. And if a is greater than 0, you can see that as x approaches negative infinity, the function approaches 0, comes down into that point. So that's what all this fancy notation means. You already understand it intuitively, but this is how you would express it. All right.